Hey everyone. Sufu?
Hello, yes.
Are you facilitating this now?
Yes, Mola, it looks like Mola is not joining us.
Fine. Okay.
So we agreed that
Thank
if he's not
I thought you
there,
were
I
on
will be.
leave.
Uh,
I thought you were on leave.
yes, but we already agreed this before I went on leave, so that's why I plan to be there.
Fine. Thank you.
So shall we start? Wait 5 minutes?
It doesn't start till 2:15.
Okay.
And before we launch into these questions that you've suggested, you'll make sure to get some Q&A in from the participants, Sufu?
Okay.
Super. Thank you. Sufu?
Yes, I'm here.
Great. It's also worth being aware that we don't know if anyone from the Namibian Stats Agency has accepted and will present in that session. So maybe just make that kind of aware before you introduce the campus team from ONS, okay?
Okay.
Thank you. Sufu, last point for you.
Yes.
So from ONS, presenting from the ONS Data Science Campus will be Celia Minas and Lawrence Jones.
Okay, Celia
Minas.
and Lawrence Jones.
Yes.
Okay.
Thank you.
Mola, so are you
Yes.
going to facilitate?
I think Garnet offered to facilitate the
It's all right,
webinar.
Mola. I didn't think you'd be. No, Sufu, it was you. Sorry.
Okay, I didn't know you were coming. Okay, no problem.
So Garnet, is that a no or a yes?
It's on me now.
Oh,
Sufu,
on you,
okay.
on Yusufu. Okay.
Yeah.
Yeah, Yusufu,
you.
since you are here, I think you can do that. But if you want to drop out in the middle of the webinar, I can come in and support. Yeah, whichever you decide.
Okay. Well, let me just enter. He will do the other sessions. We are going to start now, right? It's
Yes, I think it's time to start.
15.
It looks like we have 29 participants joined. And yeah.
Okay. So, distinguished representative and a professional from African National Statistics Office. So, greetings to you to begin with, and thank you for joining us on this webinar on automated occupation classification coding. So we are gathering today to delve into the transformative realm of automation and data science and its application in improving the accuracy and the efficiency of occupation classification. You know that in the statistical process, classification is something that you always meet. You always need to have some text that is in free form that we need to bring to a statistical classification. And in this landscape of data and statistics, we need to stay current and agile in data handling and also in processing. It's not a luxury, actually, it's a necessity. Because of the nature of the data, the fact that there is so much amount of data that we need to process. And we need to process it fast because we need to produce the indicator to guide policy. All these things, they call for methods that are not only efficient, but should also be robust and reliable. And this is precisely why the task of occupation classification, even if it looks simple, it's actually complex and it's very important in the overall quality of the statistical production. So the Office of National Statistics Data Science Campus, which is ONS, in its commitment to leverage cutting-edge technology and data science through the regional hub, has embarked on a collaboration with the Namibia Statistics Agency with the objective to address the automation of occupation classification so as to improve the quality of assurance of the census data. So the outcome of this initiative has a potential to be a game changer in the realm of data processing and statistical analysis. And why do we consider this is important? It is important because we know that we are in a context where resources are limited and the quality of data, we are always being asked to produce more data for SDGs, Agenda 2063, climate action, and so on, and even the national policies. And we need to produce the maximum with the low resources. So if we can automate this classification, it's the way to go because it's a very cost-efficient way of having quality data. So the two objectives of the webinar, the first one is to showcase the outcome of what was done with the Namibia Statistical Agency. So the primary focus will be to share the outcome of the work. We will go into the methodologies, the challenges, and most importantly, the result. By sharing this with you, we hope that it will give a roadmap for the other NSOs that are also thinking about using automated classification, how they can use it, and what are the challenges they can have. And then the second objective is to have your feedback, so to explore with you, to discuss with you, to interact with you and hear if the problems that you are discussing here are those that you have met or that you are expecting to meet, and what we should take into consideration if you want to generalize what you have learned from Namibia and apply it for our African NSOs. Of course, we know Africa is a very diverse continent. We have diverse economies, and we are at the edge of a digital revolution. So we have a significant role to play in this narrative. And if we can adapt advanced data science technique now, it will be very important for us because it will ensure that statistics are now really available and credible in the society. And this will pave the way for informed policy decision, which of course is more important for us, knowing that we need better resource allocation and having more prosperous Africa as per the Agenda 2063. So this webinar is more than a platform for sharing and discussion. It's also a testament to our spirit of collaboration, including with NSC, National Statistics Institute of Rwanda, ONS UK, Data Science Campus, African Center for Statistics, the UN, and of course you, the National Statistics Offices, and Statistical Training Center. So we just need to say a few words about the regional hub and big data and data science, even though I am sure most of you already know it. So at its 45th session, the United Nations Statistical Commission voted to establish a UN committee of experts on big data and data science for official statistics. The objective was to further examine the benefit and challenges of big data, particularly the potential for monitoring and reporting on the SDGs. In this context, the UNCEBD and the wider official statistics community recognize the importance of adequately addressing issues such as methodology, quality, technology, data access legislation, privacy management, and finance, as well as providing cost-benefit analysis for the use of big data. So to make it possible and include regional hub in its continent. So one was established in Africa, the African Regional Hub, which is hosted by the National Institute of Statistics of Rwanda. And it is supported by the United Nations Economic Commission for Africa and the ONS UK, of course, and many other partners that has helped us, such as the World Bank. And there are many partners we work on to facilitate projects on the use of big data and data science and for sharing knowledge and newly developed methods. We have done a lot of activity. There are too many to be listed here, but we have established a steering committee. We have created our work plan. We have had a side event at StatCom. I think many of you were there. We had a workshop on web scrapping workshop. We had a questionnaire on assessing data maturity or data science readiness for African statistical offices. Now we are having this webinar on occupational coding, and we are planning other webinar on mobile phone data, opportunities and challenges of mobile phone data. And then we have also recently launched our website. We will share with you I think you have already received the communication, but we can share with you the link on the website where you can know what is going on. And then we are working with many partners, as I said, World Bank, Statistics Poland, Bank of Italy, NSA, UN Women, US Bureau of Census. We were able to bring all this together to help us to disseminate on our work. So just not to take too much time, we are going to the agenda. Basically, what we are going to do is a presentation by the ONS Data Science Campus and the Namibia Statistics Agencies, if they are there, about what they have done on the occupational seminar. So the UN Data Science Campus will be represented by Celia Mines and Lawrence John. On the Namibia statistics side, we are not sure yet who is there, but if they are there, they will have the opportunity to present themselves. So once I will have presented the work, we are going into a question and answer session. We have a few questions. You will have the opportunity to ask your questions, and we also have questions for you because it is interactive. You also want to collect some information from you. It will be for 25 minutes, and then we will go into the closing remark, and we will discuss the way forward. So that's it for the agenda. And if there are no questions now, the next item should be the presentation from the ONS Data Science Campus and Namibia Statistics Agency. Over to you.
Okay, thank you. Shall just
Yeah, sorry. Our roles have been updated to be attendees. We can't share our screen.
Right. Share our screen now. Okay.
Who is going to present?
I'm just going to present now. Just right.
Okay.
Right. Can you see the screen?
Yes, we can see the screen.
Okay, excellent. Right. Just right. Hello all. My name is Saliha Minhas. My colleagues Lawrence Jones, Jeroen Minderman, and myself, in collaboration with the Namibia Statistics Authority, have been developing an occupation coding tool. This will facilitate the quality assurance process undertaken on occupations that have been manually coded to a classification scheme during a labour force survey or census. Consequently, we have also identified best practice to adopt during the data collection and quality assurance. This presentation will lay out some of the details on the design and functionality of the tool to highlight its potential and limitations. So who are we? Our employer is the Office for National Statistics. It is the main UK government institution whose responsibility it is to produce national statistics that captures activity on a wide and diverse range of indicators on the UK economy, population, and society. We work within a department known as Data Science Campus. It spearheads the exploration and application of new technologies within data science to the production of national statistics, both home and abroad. The focus for our team is international development. In this team, we work in collaboration with national statistics offices to explore and investigate their processes that can benefit from re-engineering and adoption of new technologies in data science, as well as providing mentorship and training opportunities. Naturally, working with our international partners to build statistical capability, a lot of our work focuses on building and developing tools that complement the expertise of analysts. For example, a key processing task during a labour force survey or census entails classification of textual data into predefined categories. This can be time-consuming, manually intensive task for an analyst. Tools that assist with automation, for example, with occupation coding, can significantly ease the burden. They are designed to boost and strengthen the expertise of analysts, and in no way can they act as a replacement. Also, the tools and techniques that we develop, also we hope that they improve the accuracy and efficiency of statistical reporting and analysis. For example, data processing after a labour force survey or census can be a long, drawn-out, protracted and time-consuming process. In the case of, for example, occupation coding, it can involve highly skilled staff looking through handbooks of classification schemes to ascertain the correctness of records containing manual codes. This can be for occupations. This can be done for occupations, item descriptions, country codes, and many others. There can be thousands of records that require such verification. The large volume of checks that need to be done can result in a lot of human error. Using a tool for such tasks would render significant gains in accuracy and impart greater validity to the classification codes. Another key gain is efficiency. Verification and correction of records is a time-consuming and laborious process. This is significantly alleviated through the use of automated tools that aid, for example, occupation coding. This would free up analysts' time to tackle more challenging tasks that require more human expertise and also promote consistency. Tools that are simple in design are more interpretable and promote transparency. We also seek to develop tools that are generalizable and can be used in many different contexts. For example, the occupation coder tool that we have been developing, we have sought to develop it in such a way that it allows the ingestion of any occupation cost classification scheme. Currently, it can do matching for free text job descriptions to the ISCO, SOC, and the NASCO scheme, which is bespoke occupation classification for the Namibia labour market. Potentially, it can be potentially the tool that we develop and others that we do develop. We look to make them applicable to a wide range of use cases. We've had an ongoing collaboration with the Namibia State Stats Authority now for some time, and integral to the mission of the NSA is the collection of data on occupations through surveys such as labour force and census. We were requested to assist with developing a tool. Sorry, we were requested to assist with developing a tool that would support the quality assurance of CAPI data. This is data that is collected through a technique known as computer-assisted personal interviewing technique during an interview. And we were looking to check the correctness of this against correctness of the codes that have been entered against the NASCO scheme. We have been working closely with NSA to adapt the occupation coder tool to be operationalized for use in quality assurance of the labour force and census data that contain occupations that have been manually coded by interviewers in the field. As mentioned, the interviewer collects data using CAPI, and that occupation is then that free text description is given a NASCO code. This is a classification scheme or taxonomy that is used within the Namibia labour market context. So we're looking to the tool will then check to ensure that the code that have been entered will look into the verification and of those assigned codes. So here we have an extract from the ISCO classification scheme, and this extract is typically this is structured into 4 levels, and typically occupation classification schemes are arranged or organized into levels. The first level denotes an occupation grouping at a high level of granularity, and this is denoted by a 1-digit code. The 4th level entry, such as the one shown here, captures an occupation at the most detailed level. This extract from the ISCO classification, this is an extract from the ISCO classification scheme. Entries such as this are pivotal to enable the occupation coder tool to work in an optimal manner. The occupation is described fully. The occupation is described fully, and that will enable the tool to match up correctly to the free text descriptions of jobs input. The first column here is a 4-digit code that the tool would assign to an occupation. The other 4 columns contain details of the occupation. These columns are used by the tool to assist with matching the free text descriptions of an occupation entered in by the interviewer during a labour force survey or census. The job descriptions under the definitions column, along with the tasks included and suggestions under the included occupations columns, are all instrumental in enabling the occupation coder tool, to find the correct matches to free text job descriptions input to the tool. The tool that we've developed uses a simple dictionary matching algorithm. It is robust and well used for a wide range of natural language processing tasks. Additionally, it is simple and interpretable. We use this algorithm in occupation coding tool developed. There are other tools that perform automated coding, occupation coding, such as using machine learning, such as G-code, developed by Statistics Canada, which is a closed source, tool, and access is given by seeking permission. Additionally, the classification scheme is in a very specific SQL format that is then interrogated by SQL queries. Cascot, developed by the University of Warwick, codes free text job descriptions to primarily the SOC classification scheme. It does not allow the users to add new coding schemes such as ISCO. It also costs about £350 to purchase. The occupation coder tool that we have developed is freely available and configurable. In other words, it can ingest any occupation coding scheme that resembles the format shown in the last slide. It comes ready to use with SOC and ISCO dictionaries. It also comes replete with documentation on how to use for country-specific schemes. We have managed to operationalize the tool for the NASCO occupation coding scheme, which is customized, as I said, for the Namibia labour market. The tool transforms the occupation coding scheme input into a JSON, which is used to perform the matching to the free text job descriptions input. The occupation tool the coder tool that we have developed had a pre-existing code base that is located at this address. This original tool only coded free text descriptions to the SOC classification schemes and is publicly available. As mentioned previously, the dictionary matching algorithm employed to match the free text descriptions is simple, robust, interpretable, and well used within natural language processing. Simply, once an occupation coding scheme is ingested, the tool can be used. Unlike other occupation tools available, it does not require extensive training data, which usually adds a further layer of complexity to the tool. The drawback of the original tool was that the functionality developed only permitted the use of the SOC classification scheme. We have taken the pre-existing code base for occupation coder and developed it further so that it can ingest the NASCO classification schemes and others such as ISCO. As long as the scheme is presented to the tool in the format shown earlier, these further enhancements, then the tool can now be used for occupation coding. These further enhancements to the original package will also be publicly available. The tool is easy to use. It is lightweight in terms of computational resources required. Once occupation classification scheme is ingested, a few parameters are required to be entered, such as a path to the input data. It is then ready to be used in a straightforward plug and play manner. Given input data on free text job descriptions, it will output a 4-digit code with an occupation description from an occupation classification scheme that best matches the input data. And my colleague Lawrence Jones will take over from here.
Hi, good afternoon, everyone. So I'm going to quickly go through the structure of the tool that we have. So with Occupation Coder, we only have 2 inputs into the system, an occupational coding scheme such as ISCO, and a set of input data. So we remove the need for any sort of pre-trained model, may this be a traditional machine learning model or a large language model. And we don't even need quality assured data to start the process. Of course, we would then expect whoever to use this to then QA the outputs and double check that things are right. So the process starts with a simple cleaning process. We remove things like punctuation, do some lemmatization if required, and then try and match these inputs directly against a list of jobs in a coding scheme, such as the title goat farmer. If we find a match directly against the listed set of jobs, we can respond with a single response and return a matching code from the scheme. But if there isn't a listed job, we can take the input and do some fuzzy matching with it. Now, what we mean by fuzzy matching is we're comparing the short input string that we have with a longer descriptor as part of ISCO that has the list of jobs and the tasks associated with each code. To benefit our matching process, we often include things like the industry that someone works in, as someone whose title is farmer but has something to do with cattle in the sector might make a bit of a difference. And if we do fuzzy match, instead of returning just one code to the output, we bring the top 3 associated codes, and we also include the percentage of scores that each input matches. So it's easily digestible by whoever's reading it. So for example, if we have an input data of milks, cows, and goats, that doesn't directly correlate to a single job title, but in the wider description of the ISCO code livestock and dairy producers of 6121, that code mentions things like milking animals, goats, and cows. So you'd expect the string to match similarly to that output. Now, so this is a set of dummy data that we created just to initially test, because we don't want to show NSA's own data. So if you have a look at the data, we have a input job title and we have an input sector, and we have the code, the first set of code, which is the manual input given by a enumerator in the field, and then we have a description of what that code relates to. Now, there are 2 main issues that I'm going to talk through on this slide. The first is the ones we got highlighted in yellow. So these are examples where you have something like farmer and farming, or teacher and education, where there's it's enough detail to match at a very high level, but to get the extra granularity to hit the level 4 code, there's some sort of context that's been missing that the enumerator has filled in themselves. For instance, the teacher and education one, there's no way to tell if it's a vocational teacher, a primary school teacher, or a secondary education teacher without that level of extra input. So we wouldn't be able to get that from a coder. And the orange one is examples of manual codes being wrong, and the coder being able to find something that would better suit an output. To better represent this, here's an example of some outputs using the same data I just showed. So our outputs are here on the right-hand side. So we've got a code and its title that we believe it belongs to, and then we've got some other codes that it may belong to. For example, the ones that only have one code and no code 2 or code 3, it means that we've done this with an exact match, and based off the job title, there is a job title in the coding scheme that matches completely. So we don't need to do the fuzzy matching for code 2 and 3. As you can see, we move on then to an example of fuzzy matching. We have the job title mechanic, spelt wrong in this regard, but we have a sector of motor trade. And what this additional information has allowed us to do is we've taken the all 3 of these inputs, matched them against all the codes in the system, and we found that it matches the manual code directly on the first level. We've also offered some opportunities to look at some alternatives if the first code doesn't really fit completely. Oops. Okay, so we didn't have any quality assured data from the Namibia Stats Agency when we were running this. We had a series of pilot data that they were hoping to go through, and then we will help them with a census later down the road. So what we did is we took a portion of this 6,000 plus data set, and we created a testing set for ourselves using unique inputs across that data. We then attached certainties to inputs that we looked at to compare how we felt the occupation coder should deal with a difficult input. And we got a series of outputs where we had a 62% agreement when we just provided the top 1, 70% when we did top 2, and 76% when we did top 3 results. But the reason we've called this agreement instead of accuracy is we are not Labour Force Survey or census colleagues, so we cannot guarantee that our manual inputs were the manual codings were the best inputs. So then on these remaining 24% of missing agreements, we had a look at the reasons why these manual codes were different to the generated codes. A portion of these was because occupation coder got it wrong. So things like car wash attendant, which would fall under something like vehicle windows and related cleaners, came out as the coder focusing on the word attendant versus car wash. So you get it, you lose a bit of meaning there with inputs. And then we had a series of outputs where we had got it wrong, where the coder had found a much better response due to in our coding scheme, but we blamed this on going through 600 plus codes all at once and human error plus our lack of knowledge in this space. We had an issue with the input data from the enumerator. So this was like things like lack of data, with someone that says driver brackets transporting people lacks the information to distinguish what type of driver are we talking about, car or taxi or bus driver. Depending on the coding scheme you're using, this is an important level of granularity that is needed. And finally, we had the input data for the code list where we have categories that overlap and require this additional level of context. So for example, would a registered nurse fit under professional nurse or staff nurse? Without this level of context and knowing how the coding scheme works, you're going to run into a bit of disagreement with using computers. It's not moving. Okay, so as mentioned before, we do not mean for this tool to remove the need for human intervention. It's this to support QA. And the final QA coding itself is arguably only a small part of the wider census process of collecting data, making sure it's right, and creating the output statistics. So we need to think about the need for consistency and transparency across the workflow and how we can make gains on the efficiency of other areas independent of this automated coding. We've seen from experience chatting with NSA about this, how some of the outputs we've shown have helped direct areas for training other parts of the process. And we understand that this is a very simplistic approach in terms of machine learning. But none of these other approaches that require an extra level of capacity will remove the need for human intervention completely or address these previous workflow issues if they occur in the field with enumerators. Finally, the other limitations that we look at with machine learning and large language models is there needs to be data available. Our process works without a QA data set, and you just have to QA the outputs. If you were to build a model using machine learning, you need that existing QA data set before you begin the process. There's the capacity element where you need user ability to interact with a pipeline. And this is exponentially harder when you're talking about machine learning and large language models. You have infrastructure. Again, there's a large computing overhead working with these larger models compared to our simplistic approach. And finally, there's the ethical debate. If you don't have the infrastructure to run these models on your side of things, if you're planning to send this data off to an offsite sort of server for, say, OpenAI, is your data secure? Could it be intercepted at some point, or what will OpenAI themselves do with it? So this is all things to think about. Now, there are some limitations. We talk about data quality a lot. So we're talking about, first and foremost, the coding scheme. If you're using something like ISCO or a country-specific coding scheme, the level of detail included at each stage is different. Even within international standards, if you look at something like ISCO compared to the industry one for ISIC, there's far less detail contained in ISIC, and it's very hard to get direct comparisons when the size of the inputs are a lot smaller. And then you've got the input data itself. If you've got a load of sparse or erroneous text descriptions, you're not going to get fantastic results. You're going to get impossible matches against something like self-employed because it doesn't really tell anyone what they're actually doing. But at the same time, you need to find this balance, because if you're reliant on an extremely rigorous data collection process, then you're going to end up in a situation where an enumerator has to spend a lot more time doing their job. And if you force that upon them, they might take shortcuts to get the same sort of level of efficiency that they were doing before. And all these issues still apply to other approaches, not just our approach. So you're talking machine learning and large language models. So from our perspective, from our pipeline, what are the limitations? So it's not an out-of-the-box model for every coding scheme around the world straight away, right? We have it working for ISCO. We've done it for SOC. We know it works for NASCO. But if you're using an individual current country scheme, there's that initial level of functionality that needs to be addressed. And again, the level of detail in each of these coding schemes is going to affect the outputs drastically. And our other one is there is a general need and knowledge for for Python. We've done our best to provide to create a platform that is user-friendly and interactable, but you're still going to need near it to run the notebooks, and you're going to need an initial sort of understanding of how changing certain variables is going to change how the process works. So finally, I come to refresh on the impacts and benefits. So we've got a big potential for time savings in the QA process of data for things like labor force and census data. You're talking removing a big chunk of the ones that are correct, and you know that are correct because they match against a very specific title in your code book, that someone who is highly skilled no longer needs to do this work, and they can focus on the more complex ones that are coming in. We can highlight the shortcomings in existing processes. We've seen opportunities for improvements in the data collection side of things and the training that's going on in Namibia right now. We've tested all of our work with occupations and a minor bit on industry, but this could easily be expanded for other areas where coded data exists. One area from off the top of my head is you have healthcare with a unified medical language system and SNOMED clinical terms that this could be applied to, but no guarantees that would work. And then we have also got the benefit of developing data capacity. So this is both skills and infrastructure development, both internal country between NSOs and collaborations with ourselves, and between collaborations within NSOs within this African regional hub is the intention. Now, before I move on to the discussion points, which were just listed in the webinar outline that was sent alongside the invite, I'd just like to double check if there's anyone from NSA in the chat. I don't believe there is, but just as a brief overview, they're currently beginning their census process, and I believe that is the reason why they've been unable to present today. But just to introduce something from their side, so they've been collecting these things on the population housing census, the household income and expenditure surveys, and the labor force surveys, and have seen benefits to using this already. There have been challenges working in collaboration with us, where you've got sort of two sets of systems that are separate from each other, which is the QA process and the CAPI process for the enumeration. And there's been some challenges around working with remote collaboration, where it would be a lot simpler to work in close proximity. But as an overall output from NSA, they reckon that the advantages of using the data coding tool has reduced the time needed to validate and clean the data. They're getting more accurate results from the data cleaning exercise. They've built capacity through the use of the tool, and there is an overall reduced capacity cost of running the data cleaning exercise. Okay, that's all for us. I'd like to open it up for discussion. Any questions? Yes, Cloudy, would you like to speak?
Okay, thank you for the presentation. Maybe I missed I joined later, but for this tool, you said the tool is already there. Maybe what I have a few questions concerning the model which you used. Maybe the first question is like the source of the data that was used to train the model. That's the first question. Then another question is on the language used. I understand it's you used the natural language processing technique, but still on that one, which language did you use? Then from there, I have another question on the features used to train the model. Because on the features, we are now saying we have got standard ISCO categories, and we have a portion or option or feature for interviewer to describe the activity of the ingredient of the person. Which features did you choose on that one during training of the model? Then accuracy percentage. Then the other question is on the, should we consider the tool is should it be considered as a standard tool, or it has to be more customized according to the nation situations, like you know, when you are dealing with the categorization of these job descriptions, they differ from country to country. I submit.
Okay, I'll try and hit all of your questions. If I miss any, please let me know. So our approach is let me get the slide up. Our approach is a dictionary matching approach, which means we don't actually have to pre-train a model based off any features. So we are taking the data from, for example, the ISCO coding scheme. And this exists as a JSON dictionary in the background. And we are matching the inputs from a set of pilot data that we had with the Namibia Stats Agency against these descriptions. So there isn't a need for a model. The only features that we adjusted was we did cleaning on them to remove punctuation and extra white space, that sort of stuff, to clean up our tokens. And we had a list of stop words to remove a general set of words that are not useful. In addition to this, when you do your fuzzy matching, we used TF-IDF, which is a token vectorization approach where we've essentially we weight the inputs against how common they are. So we're saying that something that's not very common is much more important to focus on than something that appears multiple times. And then we use a cosine similarity to determine how close an input is to the correct output. In terms of us saying something is ready, we're currently working on releasing a general package that works directly with ISCO. We understand that nations have their own country-specific scheme. We are planning to include a README and a way for someone to easily extract information from an electronic copy into a format that the process can use, and then test it using that set of descriptions, although we cannot guarantee how well it will work. Additionally, I think you mentioned languages. I'm not sure if you meant whether it was which computing language. In that case, it's Python. But if you were on about in-country languages, we've currently only tested it with English I know the Stats Canada one does multiple languages, so it does at least English, French, and Spanish. I'm not saying that this approach wouldn't work with some countries that share languages or have a mixed set of language base. It's just as long as the input, what's important is the inputs match against the dictionary that you're passing in. Because if your inputs are written in French, for example, and the dictionary you're trying to match to is in English, this isn't going to work. I hope I've met all your questions.
Yeah, okay, thanks. Yeah, on language, it was more like on the data set that was used to train the model. If it was for a specific language, it could not apply to another country in another environment whereby maybe data collection was being collected using a certain language. That was my concern on the issue of language during my model training. Thank you.
Yeah, but for sure. Again, we don't train a model. It's just a process. What's important is that the input language is the same as the dictionary language that you're trying to match against. So say you have against ISCO and your dictionary for ISCO is in English. You kind of need your inputs to be in English. But for instance, I haven't looked into it myself, but there may be a French version of ISCO you can use and compare it that way, that sort of thing. The pilot data that we used was completely in English.
Hi, Lawrence. We've got a couple of other questions there. Should we move on to them? From
yes,
Emma? You were just doing that. I'm sorry. I was trying to help.
It's all right. Thanks.
Emma, do you have a question? Emma O?
Yeah, good afternoon, everyone. Lawrence, can you hear me?
I can.
Yes.
Okay, so I saw I don't know, I probably missed some parts of the presentation, but I saw you talk about accuracy and it's at 72%. So I want to know 76%. So how does this imply that this is still at a, like say, development phase or testing phase? Because if 76% is quite low, if you ask me for accuracy, then secondly, I don't think you spoke about the exact model that was used. You only mentioned like you didn't have to train your model, but I don't think I picked up on any information on the exact model that was used. Thank you.
Yeah, no problem. So on the first point, the reason why we haven't mentioned accuracy as an actual fact is the data we received was not QA'd, so we couldn't guarantee that the manual codes were correct. Secondly, the accuracy of the model greatly differs based off the input data that you're passing through. If you're passing through a single word, for instance, it becomes a lot harder to match against a description than a nice 5 to 10 word example of what the job is. Again, the model is a fuzzy matching dictionary based approach. It's not a pre-trained model like support vector machine or naive Bayes going up to something like a neural network. The benefit of this is extremely lightweight. It can be run on practically any hardware. But we do understand that the things like large language models are going to give you the extra edge when it comes to short examples that could fit into multiple categories. What we're trying to say here is that not every country has the ability to or capacity to run these large language models, which is presenting an alternative. I hope that satisfies your questions.
Yeah, it does. So does that mean that a more robust language model will give a better result?
I can't guarantee that it will. It's 100% the quality of the data will affect no matter what kind of model you are planning to use.
All right, thank you.
So we have Yutian.
Yes, thanks, Lawrence. Yeah, and congratulations on this work. I think this is very nice, especially with the lighter model. Yeah, as you said, to that can be used by like people, maybe colleagues that want to start this process. So my question is about basically about contextualization. So and configuration. Have you noticed any, like, when you apply this model to different countries or different I don't know, culture, is there a need to recalibrate the model? And also, you said that, like, longer text will be better. What about sometimes like an online job posting with like extensive, like long text? How does that perform, like, in the model?
So we've only worked with Namibia Stats Agency on this, so we haven't got the experience of how this is going to work going forward with other countries. This is kind of why we're getting involved in the African Regional Hub, and we'd love to speak with people about this. The question about job applications and having a really dense, long piece of text. We haven't given it a try using this exact model, but we know applications that have used similar things in the past. It's something we could definitely look into, or provide the means for other people to look into. But I can't give you a guarantee on how it will work at this stage.
Thanks.
Sufu?
Thank you. Excellent presentation. So we see the perspective. I have just a question about the use of the large language models. My first point is, if we are just giving the description of the job, we are not saying this description came from this person or this company. Is there really a confidentiality issue here? Because I don't see, we are not revealing personal information. We are just giving a description that we don't know, we're not telling where it came from, and we want to classify it. This is my first question. The second one is, I see the methods that you are using, TDF, EF, and dictionary. Basically, the limitation is that you are not capturing the semantic, right? You are capturing the word. So if you use synonyms of other way of saying it, it will be a problem. But the large language model can do that. And there are actually models that are not as huge as ChatGPT that you can use actually in your computer, that even can be for ChatGPT, like BERT and all these. So maybe, I don't know if you try these models that are not large, but they are also very good language models that were used before we had this ChatGPT. And I think they're also very good at capturing this kind of thing. So maybe it's something that can be tested, or I don't know if you already tested them, something like BERT. Over to you.
Yeah, so in answer to the first question about whether or not it would be ethically correct or not to send the data, because you're not putting people's ways to identify specific people, that will be down to the country and how the Statistics Agency's legal department will view it. Personally, I'm not going to weigh on it because I don't want to represent ONS in the wrong way. But you got to think that while the hope would be that you'd never pass anything personal, what's to say that one of your records within a large, say, 100,000 strong database of inputs couldn't have someone's name or their location written in the wrong column at some point? So these are just, it's not about so much the data itself, but it's the human element in collecting the data that could potentially cause an issue. And in regards to the second one with the use of LLMs, we currently do not have the capacity to to have tried this with an LLM because of our organization going through legal to determine whether or not it's safe to pass data, that sort of thing. But I have experience working with this in healthcare data, and I can say that it does reasonably do well. And the contextual elements that you are mentioning do get picked up a little better. However, there is, as Jeroen has mentioned in the chat, there is a very high computation cost or monetary cost if you're paying someone like OpenAI to test and then eventually produce a model. Before I bring Jeroen in, does that answer your question for you, Sufa?
Yes, it answers the question. Thank you.
Jeroen?
Thanks, Lawrence, and thanks everyone. This is really good. It's a really useful discussion and really interesting questions as well. I just wanted to follow up on that very last point about, I guess, the use of LLMs and the kind of, because I know there's a lot of interest in it, and this question is often asked, kind of, why not try that route? Even leaving aside ethical considerations in terms of sending data, for example, to external APIs. So that's quite a big point, as in that would need to be discussed internally in a stats office, as in, is that even appropriate to sort of send survey data just externally without reference to, or without knowledge about what specifically happens to the data once it's sent to some external service? But I would say, aside from that problem with LLMs, I think it's really important maybe to stress that, yes, LLMs might make a difference and might improve the might improve the quality of the kind of response that we're getting. Bear with me 1 second. Bear with me 1 second.
Celia, you're sharing your screen.
It's me. Sorry.
Okay. Sorry.
So bearing in mind the kind of like issues around LLMs more broadly, I think maybe a really good point to stress is to what extent will those relatively small gains, I would call them, in accuracy, really benefit the goals that you are trying to achieve as an organization with this coding? Bearing in mind that there will always be a degree needed for human QA and to kind of make sure that we're kind of following good practice in that sense. So I guess my question would be, given the large overhead in infrastructure, in skills needed, in I guess technical capacity to run and maintain models and implement them, at this stage that certainly is quite a good hurdle. Maybe in a few years' time we will all be very much better versed in this. But I think at this point in time, I think a key point from a sort of work process and the process of statistics results generation, it's worthwhile considering to what extent are those gains, those extra percentages of quote unquote agreement or accuracy, really kind of worth that specific further investment. It may be. I'm not saying it wouldn't be, and I'm not saying that we shouldn't all be looking at this, but I think it's worthwhile considering that how would this fit in terms of a work program for a stats office to kind of really start developing that capability. Are tools like the thing we're presenting here, so essentially fuzzy matching and kind of text matching based approaches, is that a good route to go down initially? Maybe to work up some training data internally, or to have it like a QA process that's quick to implement, and then alongside to really kind of look at sort of longer term implementation of some of these large language models as they're becoming a bit more accessible. So that's just my 2 cents and my sort of addition on the point about kind of the limitations around large language models here. Thank you.
Thanks, Jeroen. That's really helpful. So I'm kind of stepping in as facilitator now. Hello, everybody. I'm Garnet Compton from the Office for National Statistics International Development team. And I work closely with the UNECA and NISR on the UN Regional Hub for Data Science and Big Data. Is there any other questions for Lawrence or Celia before we maybe open it up for these discussion points that Lawrence has on the screen. Yes, we have another one from, is it Cloudy?
Thank you. Yeah, okay, on this two, is still on the piloting stage, isn't it? From what I'm getting now, it's like the two is there, but it is still needs input from different stakeholders to make it maybe a standard tool for the classification, because from what we got from the presentation, it's like the tool is there, the idea is there, but we haven't yet reached the position where we can say, yes, this is the right direction to take. Because looking from because here we are talking of much more on the labor force survey code classification, but it doesn't end there. As far as the statistical offices is concerned, there's a lot that is taking place which needs the use of this artificial intelligence machine learning tool. But as of now, surely we need to improve the tool, because there's a lot that needs to be considered. And the tool, I think, from what that's why I have asked a question on the data source that was used to train the model, because as the service changes, and you cannot apply that model to that survey. Each survey will have its own features which will need to be prioritized, things like that, and choosing another model based on the type of the survey, things like that. I think we cannot have a standard tool for that, but the idea is okay for the statistical system, the statistical offices systems. I submit.
Okay, thank you, Cloudy. Yaron, is your hand up to come in on that one? Or just
Yeah,
make a
it was
comment?
maybe briefly to just kind of make a couple of notes, if that's okay.
Please.
So, Claudia, yeah, I think it's a good point. I think in a way, I would say things can always be improved, and I think it is fair to say that we would be expecting whoever would be picking an approach like this up, we would be expecting people to look at what it does, whether it meets requirements, etc. And we would be happy to discuss it with people as well. We're very keen to hear feedback, etc. So, and I don't think we are suggesting this as this should be the approach for occupation coding or coding anything. Frankly, this is just an approach to meet a certain particular requirement that we had with NSA. So I think that's maybe important to note from a sort of quote unquote standard approach to occupation coding. It's also interesting to maybe note that even within the UK, there are different approaches to occupation coding that are used by different teams, different tools. So I would probably, frankly, from my admittedly slightly naive position, would say that there are actually many different approaches, and I'm not 100% sure whether there is a quote unquote standard approach, partially just because the needs are different. So that's one point. The second point, I think you referred again there to kind of different country contexts being different in terms of training data and data being different. Again, to sort of stress and basically point out again what Lawrence was saying before, it's really important to again stress we do not need training data for this approach. All this approach needs is data, the input data from the surveys, and the relevant coding scheme. So there is, to some extent, apart from perhaps language issues and obviously questions around the quality of a coding scheme, if that is like a tailored coding scheme, like the Namibia scheme that we were talking about in this case, if countries aren't using, say, an ISCO scheme, which is the standardized international version, all we would need is the input from that scheme. So that is the only data requirement, the actual input data to be coded and the coding schemes. So that's maybe an important thing to stress. Whereas you're very right, if we're talking machine learning models that are trained on particular data sets, and you then want to apply an approach that uses a machine learning approach, which is different to what we're doing on like different data sets, then yes, you might have questions around, and very rightly, around whether a model that, for example, has been trained on data from Ghana or on data from Namibia would be necessarily applicable in either context, because some jobs might not be represented in the same way, so the model would perform differently necessarily. This brings it back to our approach. Our approach doesn't actually necessarily have that challenge. It has other challenges, but not that one.
All right, thank you, Euro.
Yeah, if I can just come in and finish off that point real quick. In terms of what stage we're at with how this, whether or not this is a pilot or not, I think that's a good potential way of describing it, because we are piloting it with the Namibia Stats Agency right now. We are hoping to have a generalized version of the package that works out of the box with ISCO available publicly within the next few weeks, and we will aim to get that distributed via the African Regional Hub. A link to the GitHub. Thanks.
Thanks, Lawrence. That's a useful addition. So you've got some, I'm gonna, in the interest of time, I'm gonna move it on to so that we can at least address some of these discussion points and get some feedback on them, if that's okay. How did you want to handle these discussion points? Lawrence, do you want a show of hands?
These were just examples that were listed on the webinar. If anyone feels strongly about coming in on them, we're free to, we're welcome to take whoever's put their hand up.
So we'd be really interested to hear from NSOs that think this would apply to them and they'd be interested in moving it forward, either here or in writing afterwards. And can you see the potential for this in your own data processing? All right. Or if there's any other questions related to the discussion we were having, Asufu, come in, please.
Okay, so I'm not speaking from the perspective of NSO, but from ECA as an international organization. For us, some of the interest of this automatic coding is ability actually to process some information that we have inside publication, because we have this challenge that even though when data are disseminated, they are not disseminated in the form of table. Sometimes it's a textual report that we receive. So for us, it's important that we can take a piece of text, for example, this text, we know that it's talking about inflation, but we would like to know which category. Is it inflation on food? Is it inflation on, how do you call, which other category? Hotels, transportation. So by reading the text, try to know which categories of inflation it is taking. But this, it's more complex here, because that's why I was talking about the idea of capturing the semantic, because here matching only the word maybe will not perform as well as a model that can capture the meaning of the text itself, to try to guess which categories of the inflation is mentioned in the text. So that's why we will still come back to the machine learning model and maybe the large language model or the local version. We have been trying also local version, because now there are local ChatGPT that you can install on your computer. They also work, but they are very slow. if your computer is not, but still they exist, you can run them locally. And I also wanted to mention something that was in the chat from Ghana Statistics Office. They have been working. We were planning even to do a presentation together. They have also used a large language model to do this occupational classification with very promising result. And we were planning also to bring them to ECI to do some presentation. So I don't know if they are here. I think Mr. Lawrence Smith is here. He will also mention. So these are the two things that I wanted to mention. Over to you.
Thanks, Asufu. Any other comments for Celia, Jeroen, or Lawrence? One person raise their hand. Lauren, come in.
Sure. Yeah, I had a question, and I think many of these kind of projects will struggle with this this problem. Even in places where English is the spoken language, there are local terminologies for either items or jobs or business establishment or whatever type of classification you want to do that are not going to be part of the official language, the official classification language, like in across African countries, like the driver of like a public transport driver, whether that is a Mutatu driver or a Trotro driver in West Africa, will have very, and that's just an example, will have very specific terms that are commonly used, but might not be part of the official classification. What is the way to enrich such a model so that these commonly used local terminologies for certain jobs can be picked up on? Thank you.
Thanks, Lauren. I missed Tu's hand went up first. Sorry. Oh, Jeroen, you got your hand up first.
Yeah, I think Lawrence and I will probably end up making the same point. So, Lawrence, do you want to have a quick go? It's a really good point, Ladon, and one that we've definitely thought about as well. So, now, Lawrence, if you want to come in first.
Yeah, I can, and I've got a very specific example. So we run into this issue with the Kapana salads, which is grilled beef in Namibia. Without the context of that, it's kind of hard to generalize what sort of seller they are. We could get to a certain degree where it's like, oh, they are selling something at a stall or in a shop. But to get down to the fourth level code where you would need to know whether or not it's like a food product or not, that's you suddenly lose that level of detail. Unfortunately, it's something that is kind of outside of the process we can deal with in our example. That would require a level of extra context, machine learning sort of thing. But in the same regards, it can also be used to influence the training sort of for enumerators, that if you know that, or for adapting your own country's coding scheme. If you know that this is a big job title that's not covered in your code list, maybe the next revision it gets added to the notes that this needs to be added to this sort of category, or maybe that you go out in the field and you tell your enumerators that, okay, they sell this, but you also need to include the it's a food in the sector or something like that, or the extra description of the title.
Yeah, I completely agree. I was going to use the same example as well, which is funny. So just to follow up on that as well, I think the real kind of key point, which I think is why this is really interesting, when you were saying, Ladon, what could be done to sort of deal with that in this model context. Now, I actually think that's a really interesting phrase to use. If we think about the model context as being the process as a whole, not just the kind of machine learning model or whatever our TF-IDF fuzzy matching thing that we're using technically. But if we think about this on a really high level, what can we do to improve the process of occupation coding? You could see that that whole model of occupation coding, how this could work is an approach like this could be used to feed back to the teams that I guess design these coding schemes or think about what specific occupations are listed, what tasks are listed within that scheme, and the scheme can be updated through things that are missed. So we are missing maybe say Kapana seller, so we're not matching that to the right sort of thing for the sake of argument. In the case of the Namibia scheme, that wasn't a problem because Kapana seller is actually included in the scheme, I believe, but it's not included in something like ISCO. So ideally, you would want to start adapting, say, ISCO, so that it covers specific things like this. And approaches like this could be used to inform that. So it could be a cycle where we're saying, actually, we are just building the evidence. So that's in my ideal world, that's how that would work. So you would just be building more and more information that would basically be relating to street food seller, for example. The other sort of maybe side point to it, and this is, I guess, trying to not get back on my hobby horse, but this is also why I guess machine learning models and even large language models and applications like that would be really challenging in this case, because it essentially directly implies that you would need a huge training data set to be able to cover all those sort of like really niche descriptions that you're referring to. So that would even be a real challenge with any like machine learning model. You would just simply need the training data. So that's kind of, I guess, our thoughts on that. Does that help at all?
It helps me.
Yeah, thank you. That really does. Yeah, I mean, I guess our strategy at GSS has always been so far is just to make our own dictionary for terminology that is kind of almost unique to a certain code. So if you can look at all the terms you have maybe from previous surveys and rank each word for each code, and then see if there is terms that almost exclusively belong to a certain code. And if you find that word in the description, then that's likely the description, a code to belong to that description.
Yeah, and that makes total sense to me. And I think maybe kind of to stress a point that Salia was making here as well, because the adaptations that we made to the occupation coder package, I think the really important thing to note is that it will be very easy to just re-ingest an updated coding scheme, as in it builds a new JSON dictionary for you in the background. But if you have minor, or your organization has minor updates to the coding scheme, for example, the addition to an extra term to link to a particular code, then that could just be made in the original files that describe the coding scheme, and that coding scheme could be re-ingested as an update. So I think the key thing, I guess, that I'm saying is that I guess maybe moving away from this idea that updates to a coding scheme like this are like very technical and very kind of long term, because it takes a long time to do. Hopefully that is something that this could sort of address as well, as in that process will just be easier.
Sufu, did you want to come in? And then I think that might be last question.
Okay. A question and a comment also. Very often also in machine learning, we like to make several models work together, because every model has where it is strong and where it is weak. And then we can make them work together to have an even better model. I think we use it in this ensemble learning when we talk about this boosting. So in this case, for example, if this model has some kind of perplexity score, when it classifies something, maybe it know how good is the classification, how certain it is that it is a classification. So when the model is very certain about the classification, it classified it itself. And when it is not sure, when we are below a certain score, then it can send the data to another model which is better, which could be the large language model, or the local model, which is stronger, but maybe is more computationally expensive or has more risk. Then in this case also, we can make different model working together, and then we can make sure that the data that you are sending to the large language model or to the other expensive model is very limited, only where the first model was not sure. So in this case, is this also a feasible approach? And my question would be, do you have this perplexity score that tells the model how sure are you about the classification? And if you are not sure, can you send it to the other model, which is more expensive? Over to you.
Yeah, so it's a fantastic idea, and at the moment our outputs for our generalized our projected generalized package do in fact output similarity scores. So you'll have a number between 0 and 100 based off of how well something fits. So we could easily use our model as a sort of initial pass, remove everything that's got exact matches, remove everything that's like 95%, for instance, and then you've reduced your data set initially, and then you don't have such a high computation cost for the LLM. I totally agree.
And was the sort of first part of that to do with confidence scores? Was that the specific question, whether it would be possible to like output a confidence score in terms of the predicted codes? Is that, did I get that question right there, Asuf? Yeah.
Yes,
so,
exactly.
So the tool will actually do that. So the TF-IDF process gives an indication of how closely something matches text-wise. So for each of the 3 predictions that the tool would output, or maximum 3 predictions that the tool would output, if there isn't an exact match, you will get a number that represents how closely it seems to have matched something. So there is potential to kind of implement some process where you may be further filtering by how closely something matches. So if you really want to cut it down further, and you're able to or willing to sort of take a certain, like accept a certain threshold of, I guess, risk, if you will, then there is potential for using those scores in that process for sure. We just didn't show them in our outputs in this case.
Thanks very much for those answers and the last comment, Sufu. I don't see any other hands, so I'm going to suggest we close up, and I'm going to do my best at closing remarks, if that's okay. So a couple of points. That was really, really interesting. Discussion was, I think, fantastic and really valuable and wide-ranging, so quite exciting. Some things, and really exciting to see just the clear benefits of something that is reasonably, I'm air quoting, reasonably easy to implement, but has some, immediate resource savings as well, which is good and good to see, and builds on, the ability within the organization, or strengthens the organization's ability to do things like text matching, which has got loads of applications. So really pleased with that. A couple of points to note. We're going to put the slides and the recording of the document on the event pages of the website. And what we'll do is, when we've done that, we will send a link out to everybody that registered. I'd also like you to look and complete the evaluation form that Jonas has posted in the chat box. Your contribution to this is really, really important. Helps us drive our next steps and our next webinars. And speaking of next webinars, we are looking at doing, our next one is looking to be in November, around an introduction to mobile phone data for use in official statistics. And we're confirming dates for that in November, but there is also a similar presentation being done, or webinar, to the UAE regional hub on the September 26th, and we can also potentially link you to that. I think that was everything I wanted to say, other than to thank very much Talia and Lawrence for the excellent presentations, and your own for the presentations, the comments, the generation of discussion. Thank you all for your participation. And oh, the last thing I wanted to say was, if you have any questions or you're interested in taking this further with your own organization, please email Jonas. He was the one who sent you the invite to the meeting and the link to the meeting. Suggest we send and we'll coordinate responses through him. So thanks very much for your time, everyone. Thanks again, Celia, Lawrence, and Jeroen, and everyone else, and have a good Wednesday evening.
Yes, thank you. Bye.
Thank you, everyone.
Thank you. Bye.
Okay, thank you. Bye.
Thank you. Bye.
Thank you.
Bye.
Thank you all.
Thank you all. Thank you.
Bye.
Bye.
Thank you. 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 Bye.
Abayoki wasiki. Mayoki va se dire.